So what I was trying to say, how we are going to calculate the skewness. First thing is that, right? So the skewness can be calculated by summation of xi minus x bar. What is the x bar? Can anyone? The whole cube divided by ns3. So, so I think you guys can understand where xi is the point, input point, and x bar is the mean, and n is the number of data point, right? Understood? And s is what? S is standard deviation. Okay, correct. So with this formula, we are going to calculate the skewness. Hmm? So let me write down here. So what I am trying to say, where xi, where xi is equal to input, and uh, x bar is the mean. And if I'm writing x bar, means it's a sample mean. It's a sample mean. And ns is the what? S is the standard deviation. S is the standard deviation, and n is the number of data point. N is equal to number of data points. Okay. So this is the called skewness, right? So how to calculate the skewness? Just in case if you guys are thinking to calculate the skewness, so let me draw these things. Okay, let me write down this. So let's suppose let me draw it, these things just a minute on my whiteboard. Let me know if you guys can see my whiteboard or not. Are you guys able to see my whiteboard? Okay. So what I was saying, for example, the skewness formula, what we have given, skewness formula we have given like we know the skewness formula is equal to something summation of xi minus x bar the whole cube divided by ns cube, right? This was the skewness formula. This is the skewness formula, right? Now let me show you how we are going to calculate. For example, let's suppose, for example, for example, there are 65 as 65s, and there are sorry, there are three, sorry, let me stop this. So there are 365 as 365 as comma 6 6 670s and 975s. Okay, the set of symmetrical data has skewness. We are saying the set of the set of symmetrical data has skewness equal to equal to 0. Okay, where each x each x value is subtracted from the average from the average. So if a collection, so if a collection, if a collection of data is symmetrical, symmetrical for each point, for each point, for each point, that distance is each point that is a distance t. Let me write down, then I will explain this. So now in this case, if I am trying to calculate, uh, the symmetricity, how we can calculate these things, right? So to do this thing, consider 65 value, 135 value, average data. So what we are trying to consider? We are trying to consider average is x bar is equal to 100, just for example. And x value is, we have 65. Okay. So now if I'm trying to do these things with this, applying this on this formula, so what will be our formula? Formula will be xi minus x bar divided by what? S cube, right? S cube. So x1 is what? 65. And minus x bar is what? 100. Minus 100 divided by S cube. S cube means standard deviation, right? S cube, let the S cube like this. And what will be, and this will be the whole cube, right? This will be the whole cube. Now if I'm trying to do these things, with these things, can we use something? Okay, so this will be minus 35 the whole cube divided by S cube, right? And this, if you can calculate, if I'm not wrong, can anyone calculate this 35 ka cube? How much? No, I think I got that. 4278. I think this will be right. S cube. Okay, so we got this. Similarly, let's suppose, for example, let's suppose for x is equal to 135. For x is equal to 135. Now, same thing I am going to calculate here also should be whole cube. X minus xi minus x bar, the whole cube divided by s cube, and this time as x 135 minus 100, the whole cube divided by s cube equal to what? This will be 35. So 35 ka cube divided by s cube, and if you can calculate, this will be 4278 divided by s cube. This will be 42,770 35 ka cube. Let me check once again. Calculator. So you mean to say 35 into 35 into 35. Okay, 42,875. Okay, 42,875. Okay, can anyone calculate this as well? I think this will be also same, 42,875, right? Okay, 42,875, right? Okay, cool. Now, if I'm trying to sum it, both the things, what will be the result? So both the result will be zero, right? If I'm going to sum it up like symmetric of 65 plus symmetric of 135, how much we are getting? We are getting exactly zero data, right? Zero skew means this is indicating the data is completely skewed data. Yes or no? So this means like mean median. If you are getting result like this kind of thing, it means that your mean equal to mode equal to median. Can I write this? Yeah. No, if your skewness is zero, then you can write this statement. So just now I explained, right? There is a two type of skewness, three type of skewness. One is properly symmetric skewness. One is properly symmetric skewness where mean, median, yes, 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 yes. And there is another skewness which is called right skewed data. Right skewed data, right? This is called right skewed data. And similarly, that is another skewness which is called left skewed data, right? And in this case, mean is lesser than median. Mean is, this is our mean. Yeah, this is our mean. Let's suppose this is our mean and this is our median. Okay, so mean is lesser than median. In this case, mean is greater than median. In this case, this is called left skewed. What is called? Let me use different color. Um, so this is called left skewed data. Left skewed data. And this is called symmetrical data. This is called symmetrical data. And this is called right skewed data. Right skewed data. Okay, this is called right skewed data. That is fine. And this is called here what we understood here is something like mean is mean is greater than median. See what how much data is saying median. Here mean is less than median. Yeah. So now you guys can understand if someone is saying it is a left skewed data or right skewed data, you guys can answer this part, right? Huh. This skewness, right skewed data is also known as sometimes positive skewed data. So don't be confused with the right skewed. This is also called as positive skewed data. And this is also known as negative skewed data. Negative skewed data. Okay, this is also known as positive skewed data and negative skewed data. Got it? Any question? Cool. Now let's, for example, okay, let me do one thing. Move outside and I will use something. Let me draw a one graph here. So what I'm saying, for example, another example I would like to take. So example is height of the men in a college. So example is we are going to calculate. So what we are going to calculate? Height of male in a college. Okay, this data we have to calculate. So what I'm trying to do, in your college I went and I am going to collect all the height of your male student, right? So what I'm trying to do, so here is, let's suppose, so this we have three column I'm going to make, number one, number two, and here I'm going to make height, HEIGST, height in inches. This is what? Inches. And then we have uh, class mark, uh, class mark. And then we have frequency. Frequency means how many data is falling between this. So let's suppose we have 5.9 to 5.6. 5.9 say, sorry, my bad. Inches, right? We have to give result in inches. Let's see. So this is like, let's suppose 59.5 minus 62.5. So class mark is, let's suppose, 61 and frequency is 5. Means between this height, five students are falling. Similarly, I am going to calculate 62.5 से लेके 65.5. Okay, so this is coming under class 64 age, as you can see, and in this category, 18 male students are falling. Okay, the third one is like, let's suppose, for example, 68, sorry, 65 से लेके 65.5 to 68.5. 68.5. Under this range, this is coming under 67, and the number of students is falling under this category is something like 42, just for example. Now I'm going to calculate fourth student, fourth category, and the fourth category is, let's suppose, 68.5 to 71.5. 71.5. In this category, let's suppose this is falling under 70, and in this category is 27 data are falling. Now, there is one more. Let me draw this. So 71.5 से लेके 74.5. In this category, let's suppose how many data are coming? 8. Now let's draw a histogram. Let's draw a histogram. So how we can draw this thing? So let me draw a number line. Huh? And let's suppose this range is something called 59 से लेके 62.5 is falling under this category. How many data points are there in between these two things? 5. Just for example, this is showing, this is what? This axis, y-axis, is showing number of students. Number of students. ठीक है, and this axis is showing height. Now again, this is called 59.5. This is called 62.5. Now 62.5 is 65.5. This is the range of 65.5. Just for example. So in this category, how many students are falling? 18, right? So 18 is obviously 5 se bada hai. So this will go above this, just for example. So what is this? This is 5, this is 18. Now similarly, I will go 65 say 65.5 say 8.5. So let's suppose this is that range, 68.5. This is that. Now in this category, how many students are there? 42. So 42, obviously this bar graph, it will be quite bigger, right? This bar graph will be quite bigger. Is bar graph will be quite bigger. Oh, cool. Now similarly, I am going with 68.5 say, just for example, 68.5 say something here. What is that? 71.5. 71.5. In this category, how many things are there? 27. Means this is that 42. This range, if I'm not wrong, this is 42. Just for example, 42 is falling under this. 27 obviously lesser than this, right? And in this range, 27 will fall this category. And this category, I'm going to make it like this. Okay. So this is under 27. Okay. Now, similarly, 71.5 says 74.5. Let's suppose this is your 74.5. And now, if I'm going to see how many data points are there, 8, right? So 8 is something, this is 5, and this is 8. Something like this. Not, yeah. You can see this data is exactly following this kind of bell-shaped curve. This is known as bell-shaped curve, right? If I'm going to plot this number line, these numbers, this frequency graph, I can see this graph is falling under this category, the bell-shaped curve. Right? Any question? Hello. Yeah. So now if I will draw this graph like this, let me draw this graph like this in the skewness. Can you see this? This side is very much skewed. Can you see this? Can I say this is left skewed data? Right? So this graph is something like this. This is left skewed data. Can I write like this? Yeah. So we can write the left skewness, these things. Okay. So that is fine. That is fine. Now what I can say, so this kind of thing, how many things is there class, right? So if I will calculate the mean, if I'm going to calculate the mean, how many, okay, let me tell you, what is the total number of student we calculated? How many total number of students under the observation? 5, 18, 42, 27, 8. Can you add it? 5, 18, 23. Yeah, 23. 23 plus 42. How much? 23 plus 42 is 60, 65. 65 plus 27. 100. Okay. Total 100 students are there. Means we got n is equal to what? Let me use different color. Okay. So we have 100 is equal to n is equal to 100. No doubt. Okay. Now, if I want to calculate the mean, mean means x bar. Mean means x bar. X bar. So if I want to calculate the mean of these students, how can we calculate the mean of this student? Simple. You can do like 61 into 5 plus 64 into 18. This color is not. Yeah. Plus 67 into 42 plus 70 into 27 plus 73 into 8. Now guys, calculate this and tell me the result and divided by, at the end we have to divide, right? We have to divide by what? 100. Can anyone calculate the mean? Are you guys doing that? Yeah, please do calculation and tell me the result of mean. See, these are the things can be doable with the Python code, that is fine. But ultimately, we should know how we can use our mathematics term, right? $67.45. Okay. Okay. So 67.45. I'm believing on you guys. 67.45. Now, what I can do, hmm, now with the mean, now mean we have, now we can compute the skewness, right? Right? We can compute the skewness. Yes or no? We have mean, we have numbers, we can compute the skewness. Let me calculate the skewness now. And bear with me. Now, as we have, now we have mean in our hand. Our hand, we can compute the skewness. Right. Okay. So how to compute the skewness? Let me create one more table. We have already formulas, that is okay. Now let's suppose we have this class marks, we have frequency, next we have x into f. Let me write this class, and first class is how much? It's missed. First class is 61.4. So now that we have 61, and then we have frequency. Frequency is what? 5. And now if you can calculate x into f, x into f, how much? 305. Very good. Now similarly, another class is 64. And how many there? 5. 18. Can anyone calculate this? 1,152. Am I correct? 1,152. 1,152. Okay. And then we have 67. And what is the frequency here? 42. Anyone? 2,814. Okay. Now next 14. 1 4, right? 14. This is 14. Okay. Now 70. How many there are 27? Now can anyone calculate this? 1,800. Correct. And next is we have 73. How much? 8. Anyone? 508. Very good. 584. Okay, let me make it something bigger this. Okay, now what I can do, now what I'm going to do, I'm going to create a variance like, okay, how much data, my data is getting varied from my mean, right? I'm going to calculate how much my each data point is getting varied, means x minus x bar. I'm going to calculate these things. So what is our x bar? Anyone? 100, right? So do calculation, this will be 205. Oh, sorry, x minus x bar, right? So x minus x bar will be what? Anybody? X is what in our case? 61. No, no, 61. X is 61. Mhm. Yeah, x is 61 and x bar is 100. Yes. So can anyone calculate like minus 61? How much? Minus 39. Very good. So minus 39. And this same thing can be calculated these things as well. Minus 36. This minus 33. And this 30. This minus 27. Right? So we calculated these things. Now what we are trying to do with this, we are going to multiply frequency. Means x minus x bar को multiply करेंगे frequencies को. Now do it. You have a frequency this 5 and multiply these things. 29 minus 175. Okay. Sorry, you have to calculate by squaring. Just square it and then calculate this. This was the formula. Bring your calculator. It always help you. Start with complete mathematics. First one is six minus or plus. Okay. Just 6,125, right? 6,125. Second one, next, third one, 45,738. Okay. Four. Next. 20. Yeah, 24,300. Now, next, battery down. Gonna charge. Hmm, 5,000. Okay, very good. Now we understood these things. Okay. Now, now we have to create a cube as well. I think there is one more cube. This is in the square. Similarly, let me do one more thing, one more time. So x minus x bar, the whole cube into f. What will be the result? And then finally we have to sum it up and we have to calculate the skewness. Skewness formula was what? Can anyone? Summation of x minus x bar ka whole cube divided by s cube. Yes. So now you will calculate these things, these, and at the end you are going to sum it up all those things and you are getting the skewness, right? So with this, we are going to calculate the skewness of the data set, right? Hmm. So you can calculate these things, just the mathematics, that's okay. Now we are going to understand another thing. Let me open this cell type. We are going to understand another thing which is called PDF, not that PDF. It's statistics term which is called probability density function. PDF, PROBABLITY, probability density, SCAT, density function, FUNCTION. Okay. So what is the probability density function? A probability, yes, a probability density, sorry, a probability distribution or density, a probability distribution or density. Density means like how much data is coming. Distribution is a mathematical mathematical function, FNCTIN function, through which the probability of occurrence of different possible outcome in an experiment. In an experiment can be calculated. Okay, what is PDF? PDF means probability distribution is a mathematical function through which the probability of occurrence of the different possible outcome of an experiment can be calculated. If the probability of an event is higher, it's more likely that the event, today is what, Wednesday or Thursday? Thursday. If more likely that the event will occur. If the probability of an event is higher, it's more likely that event will occur. For example, For example, let me write that while tossing a fair coin. Fair means that coin is unbiased. Means like it should not be like we tossed and it is stand vertically. It should be always horizontal. So while tossing a fair coin, fair means unbiased. You can say unbiased. Unbiased coin. There could be a chance. Be there could be a chance of the possibility of two outcomes. Outcomes means what are two outcomes? Head, let's suppose head or tails. Okay, head and tails. Head and tails, which are equally distributed, equally probable. Means what do you mean by that? Like if you are going to throw a coin, it can be chance, like it can be head or tail. And what is the possibility of coming head and tail? Equal, right? It can be head, it can be possible. No matter at all. And then the probability of probable, equally probable. Sorry. So the of probability of getting head or a tail or a tail is 50%, is 50% or 0.5%. 0.5. Okay. So this is called equal probability. So type of probability. So see, this is equally probable, right? So you can't say the chances of head is occurring is more or chances of tail occurring is more, right? Did you understood what I'm trying to say? Yeah, it's equally probable. Like we can't say what is the most probable thing here. So the types of probability, what we are going to understand now, the types of probability. TYPES, types of probability distribution. PROBABLITY, probability distribution. DISTRIBUTION, distribution. So there are many different many different types of many different types of probability distribution DIS, distribution. Some of them which we will be covering in this number one, normal distribution. Number two, Bernoulli distribution. Bernoulli's distribution. Number three, binomial distribution. Number four, uniform distribution. Uniform distribution. So we will learn these things, and there is one more. Number five, students T distribution. STUDENTS. Student T distribution. Okay, student T distribution. Number six, Poisson distribution. POI double S-O-N, Poisson distribution, Bistrition distribution. Okay, so let's discuss each of them one by one, and then we can come at the conclusion, right? Hmm. So let me talk about first of all binomial distribution. Okay, so so just a minute, allow me some time. Hmm. And also, you guys can go to the YouTube to fair understanding. Just check in Fibron. There is a playlist I have been created long time ago, which is called Stats. Just a minute, transformer, rasa, envelopes, example, statistics. Yes, yeah. If you if you can go to this statistics part one, statistics, data science, statistics. You can see all the distributions I have been covered. Okay, so I will do one thing. I will share this register library. Just a minute, let me go to the statistics of this one. So you guys can watch this playlist. I am adding in your reference doc. So reference doc, please watch this. Must needs to be watched before coming tomorrow class. Next class, I'm expecting everyone should watch this video, this playlist. Okay, I explained very clearly. Watch, must watch this, must watch this playlist. And let me do one thing. Just allow me one minute. I have created this presentation as well. Let me share with you guys so that you guys can use that part. Just a minute. Hmm. Yeah, I was talking about this slide. That was I prepared long time ago. So I will do one thing. I will do share these slides as well. So what is the statistics? What are the things we are doing? What are the different type of statistics is there? And also major category of statistics. We have discussed about the inferential statistics and descriptive statistics. Then we discuss about mean median mode, which is called central tendency theorem. Then we are going to do statistics analysis process. What are the different type of what are the process to do any kind of statistical analysis? There are four steps in the statistical analysis process. Number one, find the population of interest that suit the purpose of your statistical analysis. Number two, Draw random samples that represent the population. Number three, compute the sample statistics to describe the speed and shape of the data set. Make inference using the sample calculation, apply back. These are the things. And data distribution, for data distribution, we have seen like range, frequency, central tendency theorem, and how to calculate mean, median, mode. That is also we have seen. What is the percentile? Okay. So, so if I'm talking about percentile, what do you mean? How many of you know what is percentile? So let's suppose we have a data called, mm, we have a data 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9, comma 10. So if I'm talking about 10 percentile of my data, means my 10 percentile is coming where? This position, can I say? This is only my 10 percentile. If I'm saying my 10 percentile data is less than 5, my 10 percentile data, okay, first of all, this is my 10 percentile. If you can see, if I'm saying 20 percentile, this is total 100, right? So if I'm going to distribute this 10 data point into 100 percentile, each point is capturing how much percentile? 10 percentile. So 10 percentile is data my coming this. 20 percentile, if I'm saying 20 percentile, my data is coming this. If I'm saying 30 percentile, then my data is coming this. If I'm saying 40 percentile like this, 50, 60, 70, and so on. But if I'm saying 20th percentile, remember this word, 20th percentile, where it will fall? It will fall this, only two, right? So this is that. So if somebody is saying 75 fifth percentile, so see, this is your first percentile, this is your 25th percentile, this is your 50th percentile, this is your 75th percentile, right? So percentile means you guys can understand, right? So skewness, we already discussed what is called left skew. See, this very good presentation, I made it long time ago when I was preparing this video. And then bell-shaped curve, right skew data, when we can say bell-shaped curve, curtices. Curtices means you can see this is called leptokurtic. What are the different types of curtices? See, this is also following the bell curve. This is also following the bell curve. Curtices describe the shape of probability distribution. Can you see this? This curtices, with the help of this curtices graph, you can see what is the probability distribution. Curtices there are measure the tendency of the data towards the center or towards the tail. Means courtesy helping. Let's suppose if your courtesy is very high. So courtesy is very high means, what do you mean by the courtesy very high? Means your data is very much central. Means like your data more lying on the central. See, this is your highly courtesy, right? Green color. If I'm talking about the green color, so green color is highly courtesy, means all the data is falling more about the center. But if I'm saying your courtesy negative side, right? So negative side is called leptokurtic, right? So if I'm saying your data is negative courtesy, means your data is not more central, not lying towards the center. It lie might be left or right. Can you see this? Hello, am I making sense, guys? And similarly, if I'm saying, okay, highly courtesy means positive and leptokurtic. Okay, so in this case means what I can say, your data is falling more about the center, more about the mean, more about the central line, right? Now we have discussed, okay, we already discussed about the what are different type of distribution, normal distribution, binomial distribution, Poisson distribution, uniform distribution, student test, right? So let's discuss about the binomial distributions first. So binomial distribution is what? Binomial distribution can be through as a simple probability of success or failure. Means if you have to calculate only, you know, uh, within the two class, like either head and tail, pass or failure, then we should go with the binomial distribution. Binomial distribution is not applicable where we have to calculate the probability more than two class. Did you guys understood when we should apply the binomial distribution, when we should not? When the category is only two class, only we have to take a decision between these two class, then we should go with the binomial distribution. And binomial, okay, I would say this is the homework. Please watch this video First, that's the first homework. Please watch this video and come up with these things. I will ask the question with that video. Okay, let's understand how much you guys are prepared. So please watch this video, statistics one से लेके whatever things is there. Okay, and then come up with the pointers and I will, and also you have one homework. We are going to meet anyway Saturday, right? You have homework. You have to make a notes. Whatever you understood, make a notes with this thing. And I will ask the question. You guys have to present your notes here, and you have to explain me. That's a question. That's a ask here. That's a homework. I never gave the homework this kind of thing, but it's my first time I'm asking the homework. Please come up with these pointers. Okay? Yeah. Yeah. Cool. So yeah, that's all for today. We are going to wrap it up for today. We'll meet on Saturday.